In lesson 8.6, we're going to take our understanding of the area of a circle and extend that into partial areas. So for example, you know that maybe you and your family are splitting up a pizza and you want it to be divided evenly, and you want to talk about how much does each person get. This might be a scenario where you might want to be talking about taking a slice out of a circle. So here what we notice is that we have a circle with a radius of 7. Now if I wanted to find the area of this circle, the normal area of this circle would be the radius squared times pi, or in other words, in this case, I would have 7 squared times pi, which we learned in the last unit was 49 pi. Now that's for the whole area, you guys. That means I want everything inside of this circle. And so the area formula talks about this whole circle. Now, what I want to tell you is in this particular case, something interesting happens. This angle right here in this pie slice is 24 degrees. So if I were to slice out that blue pie slice, how much area would I have? Well, it's very obvious that it would have to be less than the 49 pi that was there. But how much less? Well, it's all based on a ratio. So this pie slice is 24 degrees out of the complete circle, which was 360 degrees. That ratio talks about the size of the pie slice in comparison to the whole circle as far as rotating around it. Now what you do is you take that ratio and you multiply it by the area of the circle to find out your total value. So you would type in your calculator 24 divided by 360, enter, times 49 times pi, and in the end you would find out that your end result, when you do this, would be a grand total of 10.26 roughly. So the blue fraction that we had, 24 3/60ths, is talking about the part of the circle I want, and that's the ratio, and the pi times the 7 squared is the area of the complete circle. So the blue tells you what part of the complete circle that you want. And then in the orange is your final answer. So to find the area of what they call a sector, actually I'm going to use a different color, excuse me. To find the area of your sector, which is what I have been calling the pi piece, you take the fractional part of the circle using the central angle measurement, or the arc measurement, and multiply it by the total area of the circle. So the sector gets multiplied by the fractional part of the circle, which was the 24 3/60ths, and then you multiply it by the total area of the circle, which was the 49 pi. Our end result being 10.26 roughly. In our next slide here, we're going to find something called the area of the segment. Now, the area of the segment is telling us we're going to find the area of the sector, which we just did on the previous slide, and then subtract out the area of the triangle. So if I want to find the area of the segment, that's this part right here, highlighted in orange, which was in teal, then I find the area of my sector first. That's what we did on the previous slide. That's this pi piece. And we take out the triangle in order to do that. So if I look at what's happening, first of all, I calculate the area of my sector. From last slide, that means the big pi piece right here. I see that this was a right angle. So I look at my fractional part of my circle, which is 90 out of 360, and then I multiply it by the area of the circle. Now the area of the circle, since the radius is 5 times pi squared. So here was the radius over here. And so the whole circle has an area of 25 pi. We then take the proportion of that circle, which was the 90 out of 360, multiply it by that, and we find out that that yields, for the area of the sector, a grand total of 19,625. Excuse me. Then we look at the triangle, highlighted in green on the right-hand side here. I notice that in that triangle there's a base of 8 and a height of 3. So I use my triangle formula, and I find out that 1/2 times 8 times 3, or in other words, base times height divided by 2, 8 times 3 divided by 2, gives me 12. So I take my 19.625, which was the area of my sector, I subtract out the 12, which was the area of my triangle, and left over in the end will be the area of my segment, or in other words, that orange highlighted slice from before. So the rule is, when you're finding the area of a segment, take the area of the sector, which we learned in the previous slide, subtract out the area of the triangle, and left over is the area of the segment. Down below I have kind of a generalization. So if I want to look at what's going on from before, this A out of 360, that's the fractional part of the circle you're talking about. The pi times the radius squared is the area of the whole circle. And together, these two things give me the area of the sector. Then, what I want to do is I want to take away, of course, the triangle. So the next thing that I see is the triangle's area, right here, 1/2 base times height, or base times height divided by 2. And when I subtract that off, that triangle, in the end, I end up with the area of my segment. On this last slide, we're going to be talking about areas of, I guess, maybe a nice way to say it would be a donut. It's actually called an annulus. And so down below here, you see this word annulus. I call them donuts. The math word is annulus. And basically all you're doing is subtracting two circles. That's it. There's an inner circle and an outer circle. So the goal is the picture on the far left. And what you see on the far left is this ring. You'll notice that there is a larger radius, capital R, and that there is a smaller radius, lowercase r. And you use each of those to find the areas of the circle, and then you subtract. So here, in the middle picture, you see the area of the big circle is pi times big R squared. You see the area of the small circle is pi times little r squared. And when you get these resultant answers, that is, when you get your area of your big circle in highlighted red, you subtract off the area of your small circle highlighted in blue, and you're done. So as we look at an example, I noticed that if I told you that the big circle had a radius of 7 and the small circle had a radius of 3, then we look to the formulas, and the big circle then would have pi times 7 squared, or in other words, 153.86. the smaller circle would have pi times 3 squared, or in other words, 28.26. I subtract that smaller area from my bigger area, and what I get as a result is the answer of the donut, or the annulus, which is 125. So take the big circle, subtract out the small circle, and find the area of your annulus.